Okay, let's look at the first one, which is to expand this in ascending power using the standard series, right? This is a power series here. So first one, fx. What I'm going to do is just put 2, and after which 2 minus x minus half, to the power minus half, and 1 plus x negative 2. Now, of course, we need to remove the 2 here in front. What we could do is actually what we could do is just multiply half initially. It's easier. Okay, so I'm going to just do that. So from here, fx here, if I were to multiply half top and bottom, be 1 over 1 minus x over 2 minus 1 plus x minus 2. I'm going to use my power series after this, so it's 1 minus x over 2 minus 1 minus 1 plus x minus 2. Power series, we have 1 plus minus 1 minus x over 2. Look at this, we want to including the power of x squared, so minus 1 minus 2 factorial, then minus x squared. Okay, the second part will be then minus of minus 1 plus minus 2x plus minus 2 minus 3 2 factorial x square. Okay, that's it. So what do you call it? Simplify them. So this is x square over 4 minus of 1 minus 2x plus minus plus 3x square. Alright, then you just simplify everything. 1 minus 1 0, then 2, so it's 5 over 2x, and after which 1 quarter minus 3 minus 11 over 4x square. It's good. So once this is done, this is a part 1. Part 2 is fx, right? We want the set the equation of the tangent to the curve when y equals fx at the origin. So essentially what we need is the m tangent is essentially dy dx when x equals to 0. Okay, so essentially what we want is because this curve when x is 0, f0 is actually equals to 2 over 2 minus 1 over 1, which is actually 0. Okay, so it cuts at origin, so the y value is also 0. So when x is 0, so this case here, this will be f prime 0. So we're going to use the series here. What we get is because subsequently all the other terms, higher power doesn't matter, f prime x would just be 5 over 2 minus 11 over 2x plus dot dot dot. All these, the higher degree would contain x for f prime x. So f prime 0 will be 5 over 2. When x equals to 0, y equals 0. So equation of tangent will be y minus y1 mx minus x1. We can just substitute all. This is 0 0, so this is y equals to 5 over 2x. Okay, so that's the equation of tangent. Essentially, you don't even need to use calculation, you can just state. Okay, so that's all. So part B, using the standard series given by MF26. So this is MF26. Okay, or otherwise, show that the first 3 non-zero in the Maclaurin series of Ex can be expressed as this, where P and Q are constant to be determined. Okay, great. So let's look at this, part B. E 1 plus x, square root 1 plus x. So we need these two standard series here. I think the first thing is to change the E up here, which is 1 plus x to the power of half. Alright. Then 1 plus x, so E, this will be 1 plus half x plus half half minus 1 over 2 factorial x square plus dot dot dot. I think is to where we need to look at, okay, to x cube. So we need to change the x cube there. We need to expand it to x cube. So I'm going to put this to x cube. Half minus 1, half minus 2 power series, x cube plus dot dot. Just key in calculator. So this will be e 1 plus half x. This would be negative 1 over 8x square. This is 1 over 16x cube. Okay, look carefully for the standard series of x, right? We can't include the constant there. You cannot substitute the constant, so you need to separate it out. So separate this out, what we get is e. Okay, the reason why we need to put this out is because we can't include a constant in the substitution. So it's 1 e half x minus half x square plus 1 over 16 x cube. Okay, now what we need to do is just replace x with this whole thing here. So using this series here, expansion, I'll replace x with this whole chunk here. So it's e 1 plus half x minus 1 over 8 x squared plus 1 over 16 x cubed plus 1x plus minus 1 over x 16x cubed square over 2 factorial plus half x minus 16 over 3 factorial. Okay, there you go. This is it. For this case here, what we get is e 1 plus half x minus 1 over 8x square plus 1 over 16x cubed. Then this case here, the top, square it. We don't need the intermediate ones because I think do we need the intermediate ones? We do need the intermediate ones. So but what we can do is I can just ignore the x cubed there because x cubed multiplied by anything will be non-relevant, right? So I'm gonna put this as half x minus 1 over half x square. Square it. Okay, then later we expand this. So then this guy here, I need this 1 over 8x cubed. This is the lowest degree, 3 factorial. The rest I can just ignore. Okay, so this cube, so we'll get it. So once done, this will be e 1 plus half x minus 1 over 8x square plus 1 over 16x cubed. That will be minus 2 1 over 8 x cubed. Then I ignore the power of 4 because I don't really need it. It will be 1 over 48 x cubed. Okay, then you just expand the rest, calculate out the remaining. So that's it. Once we get it, this will be e 1 plus half x plus 1 over 48 x cubed. So what we need is to find the value of p and q. P is equal to half, q equals to 1 over 48. Okay, that's how you do this part here. I think generally what you need to understand is we could just ignore this by just squaring this. Okay, the square, just bring it in. The higher degree I just ignore. So that's how we do this question here.